They say if you dig deep enough into your blood, it tells you where you belong. But what if your blood lies? What if everything you've been told about where you come from is wrong? In the world's largest island nation, with over 17,000 islands and 500 ethnic groups, you'd expect ancient roots, unbroken traditions, and proud lineages stretching back to the dawn of time. But when scientists ran genetic tests on over 6,000 people, the results shattered everything. The DNA didn't match the myths. There was no single native origin, no pure bloodlines, and no sacred ancestry untouched by outsiders. Every group from Java to Papua carried foreign echoes: South Asian blood in Bali, Middle Eastern traces in Sulawesi, Chinese ancestry buried deep in the Papuan highlands. And then there's the case of Najwa Shihab, one of the nation's most celebrated voices, Arab by name, culturally rooted in Islamic traditions. But her DNA is just 3.48% Middle Eastern. The rest is a cascade of South Asian, North African, and even genetic fingerprints from places her ancestors never named. How can someone be fully Indonesian and yet genetically scattered across the continents? Is it the adoption of culture or the inheritance of blood that defines who we are? In 2019, a groundbreaking study by the Eichmann Institute revealed what no one wanted to admit. Every Indonesian alive today is the child of migrants. Waves upon waves over tens of thousands of years from Africa, Vietnam, Taiwan, and India. Some walked, some sailed, and all left traces. But the most disturbing part is that even the so-called first Indonesians, the original settlers who arrived 50,000 years ago, are mostly gone. Their genetic signature erased, their story overwritten by later migrations. They crossed oceans before history began and vanished before it could remember them. So what does it mean to be from here if no one is truly from here? And if the very first people disappeared, who took their place? To find the soul of this archipelago, we won't look in temples or flags. We'll look inside the genome, the one place history can't hide. Because somewhere locked in the double helix is the story of a people who were erased and the truth of who we really are. But what if that truth is missing? Not hidden, not buried, just gone. Scientists once believed Indonesia was home to one of humanity's oldest continuous bloodlines, that the first people to settle here 50,000 years ago were our direct ancestors, and that we today were their living legacy. But then came the girl in the cave. In 2015, deep inside Ling Panning, a limestone chamber in South Sulawesi, archaeologists uncovered a child's skull, 7,200 years old, perfectly preserved, the oldest genome ever sequenced in island Southeast Asia. They thought she would confirm the myth of unbroken ancestry. Instead, she shattered it. Her DNA told a story no one expected. She carried genetic traces from Denisovans, the mysterious archaic humans once thought extinct in Siberia. She also carried deep Asian ancestry from a population that no longer exists. But here's the twist. She shares no direct genetic link with modern Indonesians. Not Austronesian, not Papuan. No living group descends from her people. This wasn't just a lost tribe. This was an entire branch of humanity that vanished without leaving a trace in today's genome. The team from Griffith University and Pusat Penelitian Archaeology Nasional confirmed it in 2021. Published in Nature, a new mystery lineage that rewrites the entire migration map of Southeast Asia. And yet, no one remembers her. Not in story, not in ritual, not even in blood. It's as if history skipped a chapter. She and her people crossed Wallacea before farming, before temples, before empire. They hunted, painted, and buried their dead with care. But over thousands of years, they were overwritten by waves of newcomers whose genes told louder stories. Her name is forgotten, her people were erased, her DNA nearly extinct. Which leaves us with a haunting question. If the first settlers left no legacy in our genes, who did? And what kind of migration was powerful enough to erase the island's original memory? Two waves, one collision. The answer is not one migration, it's two. Two waves of people crashing into the archipelago from opposite directions. One from the north, one from the east. Neither knowing the other existed until they collided. Around 4,000 years ago, a quiet revolution began in Taiwan. Farming, pottery, and sailing technology advanced enough to challenge the sea. These were the Austronesians, A group so mobile their languages would one day reach Madagascar, Hawaii, and Easter Island. But before all that, they passed through the Philippines and entered Indonesia, not as conquerors, but as planters, storytellers, carriers of culture. And as they moved, their DNA moved with them across coastlines, across islands, across generations. Chromosomal analyses reveal their genes spread at an astonishing 0.9 kilometers per year, one of the slowest invasions in history, and one of the most permanent. But just as these Austronesian farmers were stepping onto Indonesian shores, another wave was rising. From the east came a return, a prehistoric back-migration from New Guinea, surging westward into Wallacea. Genetic studies published in PNAS in 2022 revealed the shock. Up to 75 to 100% of Papuan-related ancestry in modern populations comes not from ancient settlers, but from this powerful second wave. These weren't scattered drifters. They came in force with boats, with kin, with languages that reshaped entire islands. And in the middle, Wallacea became the arena. Two genetic titans, Austronesians from the north and Papuans from the east, met head-on in a zone where land was scattered and nothing could be held forever. They didn't fight with weapons. They fought with genes, with marriages, with myth, with memory. And as these two worlds intertwined, they didn't just erase the first people, they erased each other. Because Wallacea didn't blend quietly. It fractured. It fused. It became a genetic battlefield. And one ancient chain of islands still carries the scars of that collision in its people, in its bones, in its languages. And in the next segment, we go there to Wallacea, the broken bridge between Asia and Oceania. Where history didn't settle, it exploded. They called it a barrier, a dead end between two worlds, Asia to the west, Sahul to the east. But Wallacea was never a wall. It was a gateway for tens of thousands of years. This scattered chain of islands, Sulawesi, the Maluku Islands, was the only place where ancient humans dared to cross deep ocean. No land bridges, no guarantees, just instinct and boats. But Wallacea didn't just connect land, it connected lineages. And now ancient DNA is exposing just how strange, how crowded, how overwritten its past truly was. In 2022, researchers sequenced the genomes of 16 ancient humans from Wallacea, spanning 2,600 to 250 years ago. From limestone caves in Sulawesi to burial sites in the Maluku Islands, what they found didn't match any living population. These ancient people were genetic mosaics, not purely Papuan, not purely Austronesian, but something in between, a swirling mix of ancestries that no longer exist in that form. Ghosts of migrations that didn't just pass through, they clashed, merged, vanished. Northern Wallacea, like the Maluku Islands, showed early Papuan and Austronesian mixing. But southern Wallacea, like the Lesser Sunda Islands, carries genetic threads tied to mainland Southeast Asia, a signal that predates the great Austronesian expansion. It means these islands were never isolated. They were crossroads, places where languages, rituals, even burial styles changed with each passing century. And yet, much of that story is gone. Modern Wallacea populations don't match these ancient samples. The genomes from centuries ago are full of ancestry combinations that have since faded, replaced by stronger waves, louder genes. Archaeologists find foreign pottery styles alongside local tools. Linguists uncover words with roots in Vietnam, Papua, Taiwan, all spoken in the same village. And still, the genetic record doesn't align. Because while it isn't a bridge, it's a battlefield where memories compete to survive. The deeper we dig into the soil, into the bone, into the double helix, the harder it is to find the original story. And yet, there's one island where the old blood still speaks. A place where forgotten ancestors never fully disappeared. They just waited to be found. The silent fathers and remembering mothers. But not all ancestors are easy to follow. Some left no names, no graves, no monuments, only a question. Who were the fathers of Indonesia? For years, scientists traced family lines through the Y chromosome. The genetic thread passed from father to son. It's silent but stubborn. Unlike culture, it doesn't lie. And what it reveals is a strange divide, a fault line through the male genome splitting east from west. In the western islands, Sumatra, Java, Borneo, The dominant Y DNA haplogroups are O, M119, O, P203, and O, M95. These are signatures of East and Southeast Asia migrations, male lineages that likely came with Austronesian farmers from the north sometime after 4000 BC. But in the east, in Flores, Maluku, Papua, everything changes. Here, the Y chromosomes tell a deeper, older story. Haplogroups C, M, and S, lineages rooted in Melanesia, some dating back more than 40,000 years. Fathers from the time before agriculture, before metal, before written memory. And here's the twist. These ancient male lines still dominate the East even today, which means something unexpected happened during the Austronesian expansion. Culturally, yes, they spread languages, rice farming, even religion. But genetically, especially paternally, they barely left a mark. In 2010, a sweeping genetic survey across the islands confirmed what few expected. The Austronesians changed the culture, but not the bloodline. They didn't replace the men. They joined them, and sometimes didn't even stay. It's a reminder that expansion doesn't always mean conquest. Sometimes it's quieter, a story told through children born of foreign fathers. And the more we map these male lineages, the clearer the silence becomes. Because while fathers crossed oceans, not all of them stayed long enough to leave sons. Fathers came from far, but left fewer sons than we thought. But while fathers disappeared, the motherline never forgot. She remembered who walked these islands first. And in her mitochondrial code, she kept their names alive. Because while Y chromosomes whispered across generations, mitochondrial DNA screamed through silence, passed from mother to child. Maternal DNA doesn't skip a beat. It doesn't fade like surnames. It doesn't vanish in the arms of empires. It flows steady, soft, and stubborn like a river beneath the soil. And when scientists traced that river, they found something astonishing. In western Indonesia, Java, Sumatra, Borneo, the motherline carried signals of the north. Haplogroups like B5A, B4C1, B3Y2. These lineages echo from the Asian mainland through the corridors of Austronesian migration. But in the east, the river turns dark, deep, and ancient. Here in Wallacea and Papua, the maternal DNA tells a very different story. Haplogroups F1A4, Q1, Q2, and something else. The Polynesian motif B4A1A1A. It's rare, subtle, but powerful. You won't find it in Western Islands, barely even in Central ones. But in the East, and especially in Sulawesi, it lingers, and that changes everything. Because B4A1A1A is the genetic compass that guided the Pacific, the thread that links Indonesians to the vast Polynesian triangle all the way to Hawaii, Rapa Nui, and Aotearoa, and its presence in Sulawesi suggests something bold, that the great Polynesian expansion, the last massive human migration, may not have flowed from Java or Bali or the Philippines, but from this middle island, a place often overlooked, a place that motherlines never forgot. Even more intriguing, eastern islands like Ternate and Tidore still preserve matrilineal traditions. Ancestral property passed through daughters, not sons. The echo of women not just birthing lineages, but protecting them, because motherlines are rivers. They bend, they curve, they bleed into new channels, but they never dry out.